All right, ladies, so we're trying to figure out how we're going to graph these functions that are not in our normal transformational form. So we want to look at a function 3x minus 4 over x plus 3. So how do I actually graph that? Well, similarly to the other ones, you want to identify your vertical asymptote and your horizontal asymptote to begin. All right, so let's see what we got here. Vertical asymptote, still same concept. What value would make this denominator equal 0? And I think that would be -3. And then our horizontal asymptote, we kind of derived this rule, right? To figure out our horizontal asymptote, we divide the coefficients in front of x. So let's see, 3 divided by 1 would give me a horizontal asymptote of 3. Okay, so now let's sketch a graph. So I'm just going to make an xy axis, and then really it's really just a sketch, so you don't have to be perfect about this. You're just getting an image of what you would see. Okay, so horizontal asymptote at 3, 1, 2, 3. I'm going to use a different color pen, and there's my imaginary line that my graph is going to trend towards. And then let's see, vertical asymptote of -3, I'm going to go left 1, 2, 3, and I'm going to make a vertical asymptote at -3. So the only other piece of information I need to know is, are my curves going to go in these two quote-unquote quadrants, or are they going to go in these two quote-unquote quadrants? All right, so how do you do that? It's actually pretty simple. You just need to know one point. If there's a point in this quadrant, then I know that my function's here and here. If there's a point up here, then I know that it's here and here. So you just test. There's a great value that tells you a lot of information, and I don't know, you might be familiar with it, the y-intercept. So if I examine this function at 0, it should tell me a lot about this graph. Let's see, 3 times 0 minus 4, and then 0 plus 3. Let's see where I'm getting out. I'm getting out the function at 0 looks like it's at -4/3, or -1 1/3. So look, if I know that my y-intercept is at -1 1/3, -1 1/3, that means if this point is here, I have to have a rational function in this quadrant. And if there's one here, there must also be one here. That's it. So the idea is simply identify your vertical asymptote, identify your horizontal asymptote using those rules, and then test a point to figure out where the curves go. I hope that clears some things up for you guys. Have a good weekend.